It'll come up again. Now, where we need to use a supermarket pull system to control the upstream processes. Well, let's think about this a minute. We have a stamping process up there at the start of this line. It can bang out one frame, left, right, whatever, every second. But wait a minute, you said the takt time for the line is 60 seconds. So therefore you can stamp out 60 frames for every one the line needs. What does it do to the other 59? Oh. Well, I guess we need a supermarket there then, don't we? We need a supermarket for two reasons. Number one, we don't build up a big pile of stuff in front of spot weld one, the next process in the line, and so that this expensive press can be used to stamp parts for other lines in the plant. If we ignore, for right now, there was a changeover problem in stamping. But if we ignore that for now, the stamping process can fill a 1.5 day supermarket between stamping and the spot weld number one process, the start of that line. That's 1,380 pieces, 60 a second, and 23 minutes a day. So we only have to dedicate the stamping process to this line 23 minutes out of 7 hours and 20 minutes. And we got about 7 hours to stamp parts for somebody else. So we can share the cost of that big humping stamping machine that's very expensive. Yes? Good. Next question. At what single point in the production chain can we schedule production? The pacemaker process. What we want to do is figure how far back up the line we can schedule our production to get this thing to flow. Now be careful. Whatever process we choose, everything downstream from that, and that means towards shipping, has to occur as continuous flow. It can't be batch. It's got to be continuous flow. Now, what would be nice is if we could continuously flow the two continuously flowed spot weld processes with the two continuous flow assembly processes. Then we would be right back to that supermarket. Man, everything would be slick and it just flow downstream from there, wouldn't it? The book says this is real, this is easy. My comment to that is, really? When was the last time you tried to co-locate processes that obviously belong to two different management silos? Spot weld is mechanical. Assembly is electrical. You see what I'm trying to say here? Okay. But for this exercise, and in reality, we might want to do this too. Just assume we have top management backing, because if we don't have top management backing, all this is for naught anyway. So let's assume we have top management backing, and just do it. Wow, we have a new pacemaker process. It's called the weld and assembly process, and we have a continuously flow line all the way from the supermarket on the outside of stamping all the way down to the supermarket at shipping. Cool. It's gonna flow. Number 6, how can you level the production mix at the pacemaker process? Well, we're gonna cheat here. We're gonna cheat. We're gonna jump ahead to question 7, and the customer wants delivered in every tray 20 like pieces, 20 lefts or 20 rights, and this is called the pitch of the process. 20 pieces per tray. That's the pitch. The customer wants to receive a tray of 20 identical parts. So we call that the pitch. And please note here, just for sake of information, that the number of left-hand parts is about double the number of right-hand parts. I think it's 12,000 per month of left and 640 for right. So every tray taking out of shipping. So for every tray of 20 pieces taken out of shipping supermarket, this causes something else we haven't really talked about yet, is the Kanban. Kanban is a card. And in this case, it's an order card. So for every tray, we get a one Kanban card ordering 20 more pieces of whatever type that was. So if we take a tray of 20 left out, we issue a Kanban card that orders 20. And we place that card in the next open slot, 20-minute slot, because these are 20 parts, 20 minutes of work. So we have a Hijunka box sitting out there beside our pacemaker process, and it's split up into 20-minute slots. So we put this new Kanban card in the next open, down the line here, slot in that box. And that's placed at the pacemaker, at the front of the pacemaker process, which is the weld and assembly process now. And the pieces are produced as scheduled in the Hijunka box. For example, 20 rights, 20 lefts, 20 lefts, 20 rights, 20 lefts, 20 lefts, 20 rights. And that's how we balance our load. Cool, huh? How this works. Number 7, what increment of work should be released and taken away at the pacemaker process? This is another easy question. The customer wants 20 like pieces in one tray. That's a pitch question. So the answer is 20 pieces or 20 minutes of work. Okay, now we have slid past some things, some Kaizen improvement opportunities. Actually, I would call them Kaizen improvement necessities to make this work. We blew past the changeover. We blew past some CT times. We blew past some whatever. But if we go back to our current state map, all inventory waste must be eliminated or replaced. Any process CT time above 60 seconds, because our takt time is 60 seconds. Anything above that has to be improved. Any changeover time. So anything above 0 requires improvement. Any process uptime lower than 100% needs to be improved. And we had some of those too. We had some 80s in there. And we found those uptimes, and I think I might have skipped over this before, the uptimes we get from reviewing maintenance records. The uptime. What percent of the time when you go to fire up your equipment is it available for use? Or is it in maintenance? Getting fixed. That's uptime. And also to make this a little bit nicer, we decided to add another supermarket. Remember, we already have a supermarket between assembly 2 and shipping. We have a supermarket, that's a 2-day job. Between the stamping process and our new pacemaker process of a day and a half, where stamping can fill it up 23 minutes and whatever out of every day, okay, to keep them filled up. But now let's put another one. We had one other bit of inventory out there. We had a 5-day inventory in front of stamping because we had coils there. So let's add a 1.5-day supermarket for Michigan Steel Company to deliver to in front of stamping. And let's even make it a little neater. Let's add us a Kanban or Kanban order post. So right there somewhere close to stamping, we have this post, wherever it's handy, and we stick this little frame on there, and in it we put a Kanban card. And we renegotiate with Michigan Steel to make deliveries every day in their milk run. But their deliveries, they'll come and look and pull out the Kanban card and say, oh, well, today we only need 2 coils of steel. So we're leveling out the deliveries. We're also leveling out the amount of inventory we have waiting for stamping to do something. That's taken care of through the Kanban order post. Kind of slick, huh? Now let's see how we did. Continuous flow line eliminated all the inventory waste in line and replaced other inventory waste with supermarkets. the continuous flow weld and assembly team decided, hey, we had 2 spot welds and 2 assemblies, but you know, we can improve that, and where we got 1 spot weld and 1 assembly and 1 that's part spot weld and part assembly. And our total cycle time through the 3 processes is now 165 seconds, or 55 seconds per process. Our total changeover time in this process, changing over from right to left and back again, is 0. And our uptime is 100% of this whole continuous flow process. And we've reduced the number of operators we needed from 4 to 3. So we fire the 4th one, right? No, we don't. He's got all this stuff. He learned all this stuff. We find someplace else for him in the plant to where he can help them improve like this as well. We don't fire him. It's lifetime. Remember the grand bargain? Lifetime employment. We're going to find good use for that guy. He's got a lot of training we can use other places in the plant. The stamping changeover time, or hour, or whatever, we've reduced that to less than 10 minutes. So that will add to our 23 point something minutes per shift it takes. We'll have to add 10 minutes in there just for changeover. And our pesky old MRP system was scrapped out of production control. We don't need all those lines based on forecasting anymore. We can put red lines through them all. Cool beans, huh? What do we really do here? We had a lot of fun. We talked about a lot of stuff, and we think we've done some stuff, but here's the measurements for it. Our paying to getting paid time now is 5 days. So our delay between buying the parts, incoming parts, and getting paid by our customer is 5 days. Our inventory turns is about 45 per year instead of 10. And our process control efficiency, when we add that line in like we did before, is now 3.8%. Not 0.9, 3.8%. That means that from all the time in plant, from the time you get the raw materials in till you ship it to your customer, almost 4% of that time is adding value. That doesn't sound very good, but it's a lot better than less than 1. We'll look at another picture and just talk